Here we go. So when you look at this, you should be able to kind of recognize from your last chapter what shape we're talking about right here. Okay, so if I write it like this, it might make it a little bit more recognizable.
Circle?
Yeah. And what's its center?
4.
Zero. 0, 3 would be the center, right? Yep. What would its radius be?
4.
Radius would be 4. So if I have that information, I should be able to graph it, right?
Yeah.
So my center is at 0, 3, so go to 0, 3 and put your center. You have a radius of 4, so then you want to walk 4 units in each direction. And then we'll have the boundaries of our circle. And we can actually make a circle out of that thing. And I'm not the best circle drawer in the world. Okay? But there's what your circle would look like. Is it going to pass the vertical line test?
No.
Okay, so anytime you do not pass the vertical line test, you have to give 2 points to prove that it's not a function. So you could give any 2 points that land on top of each other. The easiest ones to do would probably be those that I marked in orange at the top and the bottom of the circle. So the one at the bottom of the circle is what? 0, -1? Yeah. And the top of the circle would be 0, 4? 7. Oh, sorry, yeah. 0, 7, and 0, -1. Okay? Those 2 points would prove that it's not a function. 0, 7, 0, -1. Okay, we'll be skipping the set of ordered pairs on this one. And domain and range. For that circle, it is completely contained between what 2 numbers on the x-axis? Where is this on the x-axis and where is this on the x-axis? -4 and +4. So this thing goes from -4 to +4, including those numbers. And where's the top and the bottom circle if you scan this from bottom to top? -1 to 7. So start at -1, include the -1, all the way up to +7, include the 7. Is everybody good with that?
Yep.
All right, so that's all there is to that one.
So on Hawk's learning and stuff, will it ask it in this, like, in the order that you're doing it?
No. It will be, this is kind of a precursor to the whole chapter, not just 4.1. I'll talk specifically about 4.1 as soon as I get this done. Okay? And is this the last one?
There's some other stuff on the.
Yeah, there's some more stuff.
Yeah. This is,
But this is the last one of these?
Yeah.
Is that right? Okay. All right, so on this one specifically, I have what picture here? What is this going to make?
it's going to make a straight line.
It's going to make a straight line, right? And to make a straight line out of standard form, the easiest way to do it would probably be to use intercepts. So let's do an x-intercept and a y-intercept so we can graph this thing. When you're in standard form and you want to find an x-intercept, you simply cover up y. So if I cover up y to find my x-intercept, what is 40 divided by -4? Okay, so x-intercept is -10. I put it where the x goes, right? How about the y-intercept? Where will this thing cross the y-axis at?
-4.
40 divided by 10 divided by -10 would be -4. So a y-intercept of -4. So there are your 2 intercepts. So if we go to graph those, -10, 0, and 0, -4. Right there. Does that make sense? Okay, so if I connect those 2, I will have my line. So there is my diagonal line made by this standard form using intercepts. All right, is it a function?
Yes.
Yes, it is.
Very nice.
Okay, now domain arranged down at the bottom. You can't see mine, so I'll just put them down here at the bottom. Anytime you have a diagonal line, what do you know about the domain and the range?
Script off.
Script art, forever up, forever down, forever left, forever right. Correct?
Yep.
So your domain and your range is going to be a script R down there in the bottom. Okay? Everybody okay with that? All right. So now let's go specifically to do some 4.1 problems. So 4.1, if you're looking on your circle sheet, how did I do domain and range on this one?
You just look at where it goes, like.
Okay, so the circle, the oval exists between what two numbers on the x-axis? 0 to 4. The biggest mistake people make on these is they switch range and domain with each other. It exists on the x-axis from 0 to 4. So for your domain, you would put 0 to 4 in brackets. So we would need the keypad, go bracket, bracket. It doesn't like that. Right here. Okay, so 0 to 4. And then for our range, where does this oval exist on the y-axis? 2 to 4. So I go bracket, bracket, 2 to 4. And there we go. Everybody okay with that? Okay, so we'll submit and we'll see what step 2 looks like.
Well done.
And now it says, is it a function or not? So now you just use the vertical line test. Okay, now watch what happens. No, it's not a function. Look what happens. You got to list 2 points. So we're gonna list 2 points that are right on top of each other. So these two right here would be good. So that's at what, 2, 2, and 2, 4?
Yeah.
2, 2, and 2, 4. So then you tell. So look, when you look on your sheet that we did, what boxes did you need? Look at the sheet. What boxes did you need? You needed the domain, the range, and the yes or no, is it a function, right? And then the box that had the graph in it was what was given to you. You didn't have to give the equation, right? Okay. So just an idea, kind of showing you there how you can use that. All right, so let's move on to another one and see what happens. Now, I'm not going to go through all these because it's the same type scenario. Here's the vertical line one. You're going to give the domain, you're going to give the range, and then you're going to go to the next one. It's going to say, is it a function or not? Okay?
So wait, with that one, you would just give the domain in brackets, right?
You're going to give the domain in set notation because domain is only an X, right?
Yeah.
So let's do it because of that. So remember me telling you there were set brackets?
Oh, yeah.
Here's your set, and if you look on your sheet, this is exactly how we did it on the sheet. We did a set bracket with a -2, because that's the only X value you'll ever have, and then your range should be script R, so we'll put script R, and that should be it.
Okay, wait.
Yes,
Why do we use the set brackets instead of like the?
because there's only one number in the set,
Okay.
okay? That's the only number in the set, okay? So anytime it's the only number, use set brackets. So hit submit, or everybody okay with doing the vertical line test and saying that's no, not a function? And then you would just list any 2 points on the line. So I'll skip from there. And then one of the very first ones we did had 4 dots on it, okay? Here it is in set notation, here it is in a graph. They're going to ask you the domain, the range, and then they're going to ask you if it's a function or not, okay? So skip that one. All right, so here's one that's different. We have not done anything like this yet, so you need to write this one down. Given the following function, determine the difference quotient given here, and you don't necessarily need to write this down, but they're giving you this function, and they want you to calculate this. So I want you to think about, if I gave you this and I asked you to find f of 2, how would you find f of 2?
Plug in 2 for F1.
Every x you see in this function, you'd replace with a 2, right? All right, well, they want you to do this crazy thing, and they want you to do that because it's a lead-in to calculus. But they're saying go to function f and replace every x you see with an x plus h. Okay, so that's this part right here. Then you're going to subtract the actual f of x itself, which is -3x minus 3, and then you're going to divide it by h. So go to function f and replace every x with an x plus h. So what is f of x plus h? Let's just do that part of it. Go to function f and replace the x with an x plus h. So I would have negative 3, and instead of x, I would have an x plus h. This is probably the hardest problem of this lesson. Go to function f, which is here, and replace the x with an x plus h. So I'm replacing this x with x plus h. That's what I have written here. Everybody good with that? Okay? All right, so now I'm going to work that out. That's negative 3x minus 3h minus 3. Is everybody good with that? Now my goal is to get to this point where I have f of x plus h minus f of x, which I already know what f of x is. F of x is this thing right here, right? So f of x plus h minus f of x, all divided by h, is going to look like this. Negative 3x minus 3h minus 3. I'm going to write it down first and then we'll talk about it. Minus parentheses negative 3x minus 3 all over h. So write that down and then I'll explain where it came from. Yep. Remind me in a minute. All right, so this thing right here came from here. It was given to me. It wasn't something I pulled out of thin air. It was given to me. That's what I'm supposed to figure out. I replaced f of x plus h. Remember, f of x plus h is equal to this, right? So that is what's right here in place of this. So I have substituted for this these three terms right here. Is everybody okay with that? Okay? Then I have a minus sign. So I put a minus sign. I'm supposed to subtract f of x, which is equal to this. So this minus sign right here goes with all of f of x, and that's why I put a parenthesis around this, because this minus sign goes with all of this. What I have right here is simply what f of x is equal to, because it says subtract f of x. So I'm replacing this f of x right here with what f of x is equal to, negative 3x minus 3. Putting it in a parenthesis because it means subtract all of f of x. And then I'm dividing by h. Is everybody okay with what I have written here?
Yeah.
Anybody not understand how I got that? Okay, so now we just need to simplify that. I need to distribute this negative and simplify. So if I distribute my negative, I'm going to have something that looks like this. Negative 3x minus 3h minus 3 plus 3x plus 3. Because I had negatives inside of both of on these, and that means give me the opposite. So a positive 3x and a positive 3, and that's all over h. Okay, now what cancels?
3x and 3.
Those cancel, and I'm left with negative 3h over h, and then the h's cancel, and I end up with negative 3. So all that, and my final answer is negative 3.
What?
Yep.
I don't understand, like the top left up there, yeah, I don't understand.
Okay, so all I did for this was I was just trying to figure out this little piece right here, f of x plus h. So what I did was I went to function f, and so just before I get to that, remember what this means. F of 3 means go to function f and replace x with a 3, right? If I have this, f of 2k, that means go to function f and replace the x with a 2 times k. This means go to function f and replace the x with an x plus h. So I went to function f, I wrote this, but instead of putting an x here, I put an x plus h there. Does that make sense? See, here's the negative 3. Then instead of an x, I have an x plus h, and then there's the minus 3. Okay, Alexis?
You completely lost me.
Okay, on this part right here?
Yeah.
Okay, so this, first of all, I want to make sure you understand this. Do you understand what this means?
No.
Okay, so quickly, let me,
Can we do another one of these
Yes, if we have time, we definitely will. So maybe I should just finish this one and go to another one. But if you have a function, f of x equals negative 3x minus 3, and I ask you to find f of 2. That means go to function f and put a 2 in it. Well, here's function f. This is what function f does. Okay? If I go to function f, which is right here, and I replace the x with a 2, I will have negative 3 times 2 minus 3. Okay? Which is negative 6 minus 3, which is negative 9. So f of 2 is equal to negative 9. Okay? So what that means to you, as far as like comparing it to algebra 1, remember how an f of x is really no different than a y? So this thing right here can really be written like this. It's the same thing. This does not mean f times x. It's called function notation. It means the name of my function is the letter f, and it uses the variable x. And this is what it does. All right, so this is a linear function because I can replace it with y, and it looks like y equals mx plus b. Does that kind of make sense? Mm-hmm. All right, and so I'm just now, it's getting more complicated because now I have a variable thing here I'm plugging in instead of a 2. So when I wrote this over here, I was replacing this x with x plus h.
Where did you, oh, okay, so which equation are we fitting into which one?
Well, I'm putting x plus h into this function right here.
Okay.
Okay, and that's how I got this. So let's go ahead and finish this one, and we'll try and find another one to do here in a second. Okay, I think that might be more beneficial. So my answer to that came out to be negative 3, right? All of that. Okay. So skip that one. There's another easier problem in here too that might make that easier to understand if we do it first. Okay, so for example, this one. This one wants us to find f of x minus 1. So write this down. Write this down. And now it wants us to find f of x minus 1. So that means go to function f, and everywhere you see an x, instead of writing x, what am I supposed to write? Okay, so I'm going to take this thing right here, I'm going to rewrite it, and instead of putting an x, what am I going to put? X minus 1. So here we go. The first thing I need to write is the square root. Instead of writing x, I'm going to write x minus 1. What came after the x? So now I write plus 7. And then after that, there was a plus 9 outside the square root. Does that make sense, Alexis?
Yes.
Okay.
Do we have to put it in parentheses?
No. But you do want to simplify. Okay, so inside that square root, I can simplify these two. What is negative 1 plus 7? 6. So my final answer is the square root of x plus 6 with the 9 out here. Notice the 9 is outside the square root. So that's what your answer would look like when you typed it in. I wish I'd have done that problem first. It would have made the last one easier. Okay, everybody okay with that?
Yes.
Okay. Okay, so here's another one. Let's do this one. Okay, so write this down. So that's what h of x is equal to. The name of the function is h. It uses the variable x. A lot of times this notation makes a lot more sense when you get into an application-based problem. Like if you're doing a volume problem in calculus, volume of a cylinder has two variables. It has the radius and it has the height. And so a lot of times in an upper level application problem, you say, I want to find volume and I only want to use the variable r for radius, which means you have to write h in terms of r. Because when you have a function, you're only allowed to use one variable. And so the notation sometimes makes a lot more sense when you're doing an application problem. So the name of the function is h. It uses the variable x, and this is what it does. Now they want me to find h of x minus 1. Am I right? Yep, that's what we want to find. So what does that mean? That means go to function h and replace every x you see with a what? Okay, so I'm going to rewrite this whole thing, and every time I see an x, instead of writing an x, I'm going to write x minus 1. And I'm going to put it in parentheses because these x's are multiplied times things and added and subtracted to things. So I'm going to say negative 6, and instead of writing an x, I'm going to write an x minus 1. Okay? How about right here, the x needs to be replaced with an x minus 1. Does that make sense? And then I have a minus sign. And an x minus 1. And then a minus 20. Is everybody okay with that? Okay, now I'm going to type that thing in just like that and see if it will take that or if it's going to make you simplify all that. It may take it just like that. And if it does, then there's no reason for us to actually simplify that. Does everybody have that written down so they can repeat it back to me? Because it's going to disappear in a second for me. Okay? All right, so I first of all need a fraction, right? Not a square root. A fraction. And in my numerator, I need a negative 6? Negative 6 parentheses, x minus 1? Oh, I forgot to hit the shift key. X minus 1, close parentheses. Oh. Yeah, it does it for you, right. Okay, so then in my denominator, I need an x minus 1 squared. So parentheses, x minus 1, and I need an exponent, so square it. Not there, though. I need it out here. Square it, right? And minus parentheses, x minus 1, minus 20. So we're going to see if it will take it like that so that we don't have to simplify it. Doesn't like it. Does it say, yeah, it's not in the simplest form. Okay, so they want it, well, that's good to know. Okay, so we actually need to simplify that thing. So I have negative 6 times x minus 1 over x minus 1 squared minus x minus 1 minus 20. Okay, so let's simplify. The numerator is easy to simplify. What will it give me?
Negative 6x plus 6.
Negative 6x plus 6. Okay, denominator, do you remember how to do one of these? Square the first, square the last, multiply and double. That's the shortcut we're learning, right? Square the first, square the last, multiply and double. So if I square the first one, I get x squared. I'll leave a space, square the last one. Negative 1 times negative 1 is positive 1, right? And then multiply the two terms together and double that. So x times negative 1 is negative x. Double it, you get negative 2x. So that is what the parentheses squared looks like. Then I'm going to distribute my negative that's right here. So that's negative x plus 1 minus 20. Okay, so now I'm at negative 6x plus 6. What cancels in my denominator, if anything, or I can at least simplify? I've got an x squared minus 3x minus 18. Everybody good with that? Okay, now I'm a little worried that this may factor into something. What will it factor? A numerator, I can factor a 6 out, right? I can, but then all my ink's going to disappear, so I'm going to go ahead and factor it. Negative 6 times x plus 1. Everybody good with that? And then my denominator factors to what? What will multiply to give me 18 and add to give me 3? Negative 18, negative 3.
If you plot a negative 6 minus 1.
Oh, yep, thank you. Irish caught that. If I pull a negative 6 out, then I'm going to have a negative here to get a positive back. 6 and negative 3? So negative 6 and positive 3. Okay, so my concern was that something might cancel here or here, and it did not. Okay, now if it would have canceled, I'm pretty confident they would have made you factor it. But since nothing's canceling, I'm pretty confident you'll be just fine typing it in like this. Okay? Does that make sense? I will type it in like this just to make sure that they don't want it factored, but you should be good here. Everybody okay with that? Okay, so I'm going to erase my ink and type it in. I need the fraction. Negative 6x plus 6. Denominator is x squared. And then what? Minus 3x minus 18. Everybody okay with that? Yes. All right, submit that. Hey, there we go, work. Okay? Okay, so let's do this one. They've added problems to this since the last time I've done it. This time they want us to find g of x plus a minus g of x. So remember, g of x is equal to this. So as far as this little thing goes, that's not going to be a problem. That's just subtract this. I have to plug x plus a in for x. So g of x plus a would equal what? Let's just do that part. G of x plus a. Negative 6. Replace it with a. X plus a. Quantity squared. Minus. And instead of putting an x, what do I put? X plus a. And then we would have to subtract the rest. I was going to go ahead and simplify this and just figure out this part of it for now. Okay? So let's just simplify the g of x plus a. So square the first, square the last, multiply and double. Square the first one, what's x squared? X squared, right? A squared. Multiply and double. Multiply them together and double it. What do I get? 2xa or ax, it doesn't matter. Everybody okay with that? Okay. Minus 5x minus 5a. And then I need to distribute my negative 6. So negative 6x squared minus 12xa minus 6a squared minus 5x minus 5a. Is everybody good with that? Okay, now that's not the answer. That's just g of x plus a, right? That's what g of x plus a is equal to. So I got to take all of that and then subtract g of x. So g of x plus a minus g of x, which is what I'm trying to figure out all together, is equal to negative 6x squared minus 12xa minus 6a squared minus 5x minus 5a. That's all of the first part. Now I've got to do the second part. Minus what?
6x.
Minus 6x squared minus 5x. So what is the minus in front of the g of x going to do? Switch both of these signs, right? So I'm just going to go ahead and make that plus 6x squared plus 5x. Does that make sense? So I get this whole crazy long string. This represents the last part. Yep, so minus g of x. So here's g of x right up here, and I have to subtract it. So if I have to subtract it, that means give me the opposite signs on g of x. So I went to g of x, and I just changed all the signs. So I made this a positive and this a positive, and there it is right there. So if you want above it, you could write this. Minus negative 6x squared plus 5, minus 5x. Wasn't it? You could write that above it if you wanted. Yep, there are a lot of places you can make a mistake. So what cancels?
5x and 6x squared.
Okay, 6x squared's there, the 5x's cancel, and my answer is what's left. And how many terms do I have left? 1, 2, 3. So negative 12xa minus 6a squared minus 5a is my final answer. Everybody okay with that?
Would you have to put in order, like, negative 6a squared, would that be?
No, it doesn't matter.
Okay.
They'll take it in any order. Does that make sense?
Ooh, that was a long one.
It was a long one. Okay, I'm going to get rid of the ink. Everybody okay with it? Got it down?
Are you supposed to pull an A out of that?
No, it will not make you factor an A out. Now, if there was an A on the bottom or something you could cancel it with, you'd want to do that. But since it's just a numerator, you're fine. Okay, so there's one like we were doing. It's just a diagonal line. Give the domain a range and tell if it's a function. Okay? No, look at this one. Oh, they're even using set notation. This is new.
Oh, no.
Okay, so let's look at this.
Oh, man.
It says, so write this down. I'm glad I did this. I did not know this problem was in here. Okay, well, let's talk about what R, N, and Z mean down here, okay? R means the set of real numbers. N means the set of natural numbers. And Z means the set of integers. Okay? What you know what real is, that's everything, right?
Yeah.
Real is absolutely everything. Integers is all positives, negatives, and zeros. No fractions, no decimals. Does everybody know what the set of integers are? All the positives, all the negatives, and zero. No fractions, no decimals. Naturals, think of where is it natural to start counting from?
0.
No, when you count things, you don't start at 0.
1.
You start at 1, right? So the natural numbers are simply 1 and up. It's also known as the counting numbers. 1, 2, 3, and so on, okay? Just remember, natural means counting. If you start at 0, that's called the whole numbers, okay? All right, so it's saying you have the set of all ordered pairs, x comma y, such that x is a natural number and y is always equal to x. So it's telling you right here what the domain is. If x is an element of the natural numbers, then that means your domain is n, right? So your domain is going to be n. Oh, whoops, I marked range, didn't I? Okay, now your range, well, range is what my list of y values. Well, what is y? It's always equal to x, and x is a natural number. So if x is a natural number, that means y is going to be a natural number too. This just means the even natural numbers, even real numbers. I don't even know why they gave you those choices. But in both cases, it would be a natural number. Does that make sense? Okay. There's a square root function, which we have in our thing. Okay, let's do this one real quick. Okay? 3 steps. We got 3 minutes to get it done, but I think we can get it done because it's not too hard. The first step is to rewrite the relation as a function of x. So in other words, solve it for y. Okay? Remember, you have to get f of x by itself. Well, f of x is the same thing as y. So they just want me to get y by itself. So to get y by itself, I would move this thing over and divide by 3. So I'm going to need a fraction, not a square root.
Cube root of x.
Yes, it is. I'm going to need a fraction, and I'm going to take, and I'm going to move this thing over here, so that's going to be a negative cube root of x. So I'm going to have a negative, a cube root, 3x, and then I'm going to have a minus x outside of that, right? And an x squared. And then that's all going to be over a 3 if I divide by 3. Whoops. Okay, so see if that makes sense to you. All I did was take this thing and move it over here, and then I divided everything by 3 to get y by itself. And y is the same thing as f of x. Is everybody okay with that?
Mm-hmm.
Yes, Alexis.
Solve as a function of x then.
That's what we're doing here. We're writing this thing as a function using only the variable x.
Okay.
We're writing it as a function using only the variable x. So in other words, the y is gone.
That's the only reason f of x is a thing, so y is gone.
Yeah, kind of, I guess you could say. Just a new notation. Yeah. Yep. Okay, so I'm going to submit that. We're going to do step 2.
We only have one day.
Okay, well, this is not going to take long. All you got to do for step 2 is plug a negative 8 in.
Nice.
So look at your previous answer, replace x with a negative 8, and you'll be done with it. Step 3 will be the same type of problem. Okay? So we're just going to, so cube root of negative 8 is negative 2. Because there's a negative out front. So we got a opposite of the cube root of negative 8 plus negative 8 squared minus negative 8. You got to be careful with negative signs. All over 3. So you'll work that out, put that in. That'll be your answer. Step 3 is the same type of question. Okay? And that should cover everything on this lesson. So you guys can do your best to try and certify on 4.1 this weekend. So that's a 2 plus 64 plus 8 over 3, 72, 74 thirds.
Very nice. Acts like
It's not due until the test, but I'll be moving on. I'll take questions and move on.